Okay guys, hello once again. Today we have a fun little astrophysics lesson and a lesson in astrophysics for climate science and climate scientists. And this video is going to be called Climate Science Denies Earth's Orbit, a basic lesson in astrophysics for climate science. We're going to see that climate science actually denies Earth's orbit. And it's going to be really interesting how this works out. So please just watch. It's going to be a short, quick video. So let's continue here. So climate changeist orbital denialism. Let's call people who believe in climate change alarmism climate changeists. That would be a good name for them, climate changeists. You're a climate changeist. So climate changeist orbital denialism, climate change orbital denialism. It's really just climate science orbital denialism. Let's see, so let's ask this basic question that we address in astrophysics. What is the flux output of radiation at the surface of the sun? So flux output of radiation, that just means the intensity. What is the intensity of radiation at the surface of Mr. Golden Sun here? What is the intensity of radiation output by the sun's surface? So that's a very interesting question to quantify, to answer and quantify in astrophysics that we do in basically first year astronomy. So we use this equation right here, which is called the Stefan-Boltzmann law. So this is a law of physics. A fundamental law of physics. F is the flux, sigma here is the Stefan-Boltzmann constant, with some value which I can't recite right now, and then this is temperature to the power of fourth, and this temperature is the effective temperature. So this is the temperature basically of the surface of the sun, if it emitted perfectly. So it's, so just think of it as temperature, which it is, fine. And that temperature is 5,778 Kelvin. That temperature is in Kelvin, so that's the temperature, the effective temperature of the surface of the sun, 5,778 Kelvin. You raise that to the power of 4. Yes, here's the constant of physics, and then so you get 63 million watts per meter squared. That is the intensity of solar energy at the surface of the sun when it leaves the surface of the sun. So now, the next interesting question to ask would be, how does the sun's radiative flux change with distance from the sun? So that means, how does the sun's intensity, how does the intensity of solar light leaving the surface of the sun, how does it change with distance from the sun? And so that we use this law of physics, another law of physics, law of mathematics actually, because the law of geometry called the inverse square law. So what you do is you simply multiply Stefan-Boltzmann's equation by this factor here, which is radius of the sun divided by the distance from the sun squared. And so that's called inverse square law because the radius of the sun is a constant that's fixed, whereas d is your variable that can change. And it is on the bottom of the divisor here, so it's an inverse proportionality and it's squared. So it's inverse square proportionality. So that means inverse square law. So that means that the intensity of radiation decreases as the square of the distance from the surface of the sun. So very nice, right? This is all first year astronomy, astrophysics. So what is the solar flux at the distance of the Earth? Well, it's simple. You simply do the math, plug the numbers into the equations. The radius of the sun, we know, is 0.696 million kilometers, and the distance of the Earth to the sun is basically 150 million kilometers, 149.6. And so you plug that into the equation, and the intensity reduces from 63 million watts per meter squared down to 1,370 watts per meter squared. So that is the intensity of sunlight at the Earth. That is the intensity of sunlight reaching and falling on the Earth at the Earth's distance from the sun. Very nice, right? These are all basic laws of physics and mathematics, and we calculate this value. Let's ask a new question. Let's ask climate science what the solar flux at the distance of the Earth is according to climate science. What does climate science say it is? Look at this diagram here. This is one of the most highly cited energy budget diagrams in all of climate science. This forms the basis of climate science, and it forms the basis of climate science's understanding of the climate and the way it approaches its understanding and postulating and research into the climate. Look at the value they have here. Incoming solar radiation, 342. So why do they list 342 watts per meter squared as incoming solar radiation when we calculate via laws of physics that the incoming solar radiation is actually 1,370? So look, with laws of physics, and this is the actual measured value. This is measured, it's confirmed. We used basic laws of physics to calculate the intensity of solar radiation. That's how strong solar heat is, solar heating potential. That's how strong it is. You need to know that. It's important because it's like a force, right? You need to know how strong a force is in order to know how objects are going to react to that force, right? You need to know the actual force. You can't use some random value for the force. Like if you have a car, a race car with 400 horsepower, are you going to say that it has 100 horsepower and say this car is going to move as if it has 100 horsepower? Why would you say that when the car actually has 400 horsepower? So in this case, the sun has, 1,370 watts per meter squared, which is a force, which is, think of it as a horsepower, a power that the sun is inputting to the earth. This is the calculated value with laws of physics, and amazingly, beautifully, laws of physics can be measured, and this is the actual measured value as well. So why does climate science address that question and say that incoming solar radiation, look, right here. This is Keel and Trenberth, Earth's annual global mean energy budget, Bulletin of the American Meteorological Society. This is the highest level of climate science peer review. In climate science peer review, the incoming solar radiation is a quarter of what its value actually is. Why would they list that incoming solar radiation is 1/4 of the value that, one, you can calculate what it's supposed to be at 1,370, and two, what it's actually measured to be, which is the 1,370. Why would they list incoming solar radiation as only 1/4 as strong as it actually is when this is a force that drives the climate? That's like your horsepower driving your car. How's your car going to respond? Is your car going to respond to the actual horsepower being generated by the engine? Or is your car going to accelerate at a quarter of the force that's being, like, that doesn't even make sense. It doesn't even make sense to postulate questions like that. So why is climate science doing that? Well, of course, we know why climate science does that, if you've been watching my videos, because climate science divides right here, as you can see. The solar power, that's what this equation is here, F times 1 minus A, that's, the 1,370, but then, that we calculated previously, but then, what do? They divide it by 4, right there, you can see. So that's what they do. They divide it by 4. And why do they divide it by 4? Because they're spreading that input over the entire surface area of the Earth at once, as if Earth has no day and night. Now, does it make a difference? Yes, of course it makes a difference. Is that mathematically correct? I mean, you can do that syntactically with mathematics, sure. That's a syntactically writable equation. You can write that equation down. But in physics and in science, our equations need to correspond with reality. So is this an equation that corresponds with the semantics of reality? Is it a semantically true equation? You can write it down, and syntactically it has the form of equation, it has the syntax of an equation, but does it correspond to the semantics of reality? Is it an equation that is actually reflecting what occurs in reality? So does what occur in reality? There is what occurs in reality, sunlight spreading over the entire surface area of the Earth at once, with no day and night, as if the Earth is a flat plane, which therefore requires you to create this mathematical equation where solar energy is 1/4 of its power, where solar energy is 1/4 of its horsepower, 1/4 of its strength. And so, of course, this has become so ingrained in climate science, this approach to the climate is so ingrained in climate science that in their energy budget diagrams, they don't even show you that what they've done is divide solar power by 4. They don't even show you that that's what's done. They just state it directly. They just directly state, this is the solar power. Incoming solar radiation is 1/4 of its actual value. You wouldn't know that unless you've done the research that I've done. If you've been following me, obviously, right? And you know what's happening here, what they're actually doing with the numbers. If you just saw this diagram, you would think that this is what solar power is. And you would never question it because you wouldn't know any better. So you would just say, oh, so incoming solar radiation is this, 342. By the time it reaches the surface, it's only 168. Okay, well, use Stefan Boltzmann's equation, the law of physics, and you can calculate what temperature that's going to be, what temperature sunlight can generate. And if you plug that through the equation here, you find that, 168 corresponds to minus 40 degrees Celsius worth of horsepower. so to speak, worth of power, worth of heating power. And so you'll think, wow, the sun can only heat things to minus 40 degrees Celsius on the Earth. Wow, the sun is pretty weak. Actually, the sun actually has almost nothing to do with creating the climate, because most of Earth's climate exists at a temperature above minus 40 degrees Celsius. And so you would say, since most of the Earth's climate exists at a temperature above minus 40 degrees Celsius, but that's all that the sun can do, then there must be something else that's creating the climate. And then so that's the epicycle, which I've talked about in previous videos, this fake epicycle that was invented to explain why the temperature of the climate is warmer, where they amplify the heat input twice over with recycling heat flow, which is also, in violation of the laws of physics. You cannot recycle heat, but nevertheless, that's what they do to explain a higher temperature planet than minus 40 degrees Celsius. They recycle heat a few times and then say that's how the climate works. Now, obviously, what would the difference be? Oh, actually, this is really good. So here's the denial of Earth's orbit. So if you were to just take this, if you were to just see this diagram and see that, oh, Earth's incoming solar radiation is 342, then you can just work backwards through the inverse square law equation and calculate what the distance to the sun is. And what do you calculate? You calculate then, if you use that value, that the distance to the sun is 300 million kilometers. That's what you calculate, instead of its actual value of 150. So you calculate that the sun's distance is twice of the sun's distance. So isn't that interesting how we have these contradictions? Well, let me step back for a moment. Just remember in my book, in my first book, In the Cold Light of Day, how I demonstrated that there was this really basic and obvious mathematical result of their equations for this epicyclic heat recycling greenhouse effect. And I demonstrated with a mathematical proof that the equations for this model with flat Earth and cold sunshine, that the equations for this model result in a solution where 2 equals 1, where 1 equals 2. And I said, so obviously, since that's impossible, it shows that the model is incorrect, because if the model results in a contradiction in mathematics, well, that's what you call a mathematical disproof, right? Because 1 does not equal 2. And so I demonstrated that math with a completely different analysis than this, but nevertheless, isn't that interesting that here is a completely separate example, a completely separate mathematical analysis, which results in that same contradiction, that 2 equals 1. That the distance to the sun, according to climate science, is twice of its actual distance. So that's, again, an example where the equations are resulting in 2 equals 1. So isn't that amazing that that comes up in totally disparate analyses of their climate model here, of their understanding of the climate? It shows that there's consistent contradiction, which means that their model is wrong, that their understanding, their approach to the climate is wrong. Like, obviously, guys, right? Their approach to the climate is to say that the sun is a quarter as strong as it actually is. How is that a useful approach to the climate? Their approach to the climate is to say that the sun doesn't create the climate because the sun is as quarter of its strength, which makes no sense because the sun is its actual strength right now, falling on the ground, right? Like, that's what it is. So, and then compare that obviously to my model, right? So this they call an energy budget diagram. And so what I've been demonstrating is that you can create the exact same thing, but you can, an energy budget diagram, a global average energy budget diagram, but you can base it on physically realistic depictions and analyses. For example, use a spherical Earth with sunshine falling on only half of that Earth at any given time. And obviously the intensity of sunlight is most at the equator and falls off toward the poles. That Earth is rotating underneath it. And when you do this correct analysis, you use the real power of sunlight. You use its actual, quote unquote, horsepower, the actual strength, the actual force of sunlight as it actually exists. Instead of a quarter of its power, you use it as it actually exists. I mean, come on. Why do I have to explain these things to scientists? Like, come on. So anyway, it's the real power of sunlight is 121 degrees Celsius when it comes into the Earth, and it drives physics on the surface of the Earth, up to around that temperature. And so obviously, if you're driving the Earth with such a high temperature, the physics and the climate on the Earth with such a high temperature, not minus 40 degrees Celsius, but upwards of plus 90 degrees Celsius, well, then you're going to generate all sorts of physics, aren't you? Then you're going to generate all sorts of climate all by yourself with the sun only. That's enough power for the sun to send lakes worth of water vapor to 30,000 feet altitude, for example, right? I mean, how wonderful to have your theory of climate and theory of sunshine agree with what sunshine can actually do. Whereas in their model, can sunshine drive? Like, look, their sunshine input of minus 40 degrees Celsius, which is this 168 watts per meter squared converted to a temperature, minus 40 degrees Celsius, that cannot generate this, what they show here, latent heat release. Minus 40 degrees Celsius input from the sun cannot generate what they depict here, latent heat release. Latent heat occurs at 0 degrees Celsius when water changes from ice to water. There's a latent heat phase there between ice and water. And then there's also a latent heat phase between water and vapor. You need very high intensity, high power sunlight to do that. Minus 40 degrees Celsius isn't going to melt ice because ice melts at 0 degrees Celsius, not at minus 40. So this input of sunlight cannot even generate what they depict here in this diagram, latent heat and clouds and evaporation, evapotranspiration and thermals. Minus 40 degrees Celsius can't generate that. So this diagram is totally meaningless. I mean, it's meaningless in the first place because it's using a quarter of the solar power on a flat Earth, right? Even though they drew a little curve here, which is nice and cute, these are still all the numbers for flat Earth theory, quarter of the power of the sun. So with the real power of the sun, you can actually generate that evaporation, those latent heat phases. You can actually put energy into them, and you can do all that, and you can create the climate, right? So totally, it's the same thing. It's an energy budget, but we depict the Earth in a physically realistic way, consistent with the laws of physics and what's also measured. The real power of sunlight is what's actually measured. 1370, not their value at a quarter. You don't measure that. That's not what you measure in space as the solar input. That's just not what you measure. What they've done is taken what you measure and divide it by 4 because they prefer this flat Earth theory analysis. So anyway, we have a complete description of the planet here. So yeah, so orbital denialism heuristic, basis of climate physics and modern physics. So this is well accepted in modern physics, that the distance to the sun is twice the distance of the sun, which of course makes no sense whatsoever. Modern science has accepted this via climate alarmism. It's flat Earth theory, and that's what it is. Now, wouldn't that be nice, guys? Wouldn't it be nice? Could you imagine if we lived in a world where we could talk about these sort of things with scientists? I mean, obviously, there's people who are following my blog and my videos and stuff, and you fellows like to talk about this, and you know, you really are the intellectual elite of the world because you're capable of talking about this. I mean, really, you are. Because you know who can't talk about it? Wouldn't it be nice if you could talk about this with astrophysicists and physicists and scientists? Wouldn't it be nice if you could talk about logical contradictions and say, look, you know what this model does? It uses a quarter of the power of the sun, of what actually exists. And this model says that the Earth's distance from the sun is twice what it actually is. I mean, wouldn't it be nice if you could just point out logical contradictions like that and have scientists understand that it's meaningful? They just don't care. They don't think it's meaningful at all. And could you imagine if we could, if we lived in a world where we could present this to scientists and say, here's the exact same thing. Okay, I see that you guys want to create a global mean energy budget. Well, here's a better way of doing it. Instead of using a quarter of the solar power, here you can use the real solar power, and you can also use a spherical Earth and look at the different results. Do you see how the sun is strong enough now to create the climate? Here, the sun isn't strong enough to create the climate because we've divided the solar power by 4 needlessly, and you don't need to do that. If you use a spherical Earth, you don't need to divide the solar power by 4. You can use what it actually is, and then you find that sunlight is so warm and so powerful that it can create evapotranspiration and latent heat and clouds and all that. Could you imagine if we lived in a world where you could talk with climatologists about that? Instead, we live in a crazy, insane clown world where you can't talk about basic logic and things like that. What a bizarre place. What a bizarre world this is. I mean, it's really bizarre. It's just the most bizarre thing. The most bizarre thing ever. You know, and then the other thing you can do with this model is you can appreciate that the atmosphere has depth, you know? And because the atmosphere has depth, there are equations and laws of physics from thermodynamics that also apply to that. which produce what's called this tropospheric adiabatic gradient. And so that results in the fact that the average for the atmosphere cannot be found at the bottom of the atmosphere or at the top, because that's never where an average is found. An average is found always in the middle of a distribution. So since the atmosphere is distributed from bottom to top, and there's a natural distribution in temperature from bottom to top, then the average temperature of the atmosphere is going to be found somewhere around the middle of the atmosphere. And what do you find the temperature there is? You find it's exactly what is calculated, minus 18 degrees Celsius. And the bottom of the atmosphere is warmer because it's supposed to be, because of this natural adiabatic gradient. And there's no need to invent this epicyclic heat recycling greenhouse effect in order to explain the climate, when you use the actual real laws of physics with actual real things that exist, the real solar input, the real depth of the atmosphere, the actual equation from the laws of physics that apply to it. You get things that match reality. And said, what have they done? Of course, they've, used this much weaker, this much less intense solar radiation that can't create the climate, and from that they develop their understanding of the climate on, even though it's totally self-contradictory right at the very beginning. You're using a quarter solar input when you don't need to. You have minus 40 degrees Celsius input, but then you also have latent heat and evaporation in clouds, which minus 40 C input from the sun could never do. So this diagram is self-contradictory on the face of it. I mean, come on, what's going on? What is going on in this world? Is this world just meant to be a horror show? A horror show of violation of reason, of rape of reason? Why is this being demonstrated to us? What? Anyway, yeah, I won't get off on a crazy tangent. I think that was sufficient. How'd you like that discussion? I think it was pretty fun. All right, that's 22 minutes. That's probably long enough. Nice to talk to you, everybody, today. It's a beautiful sunny day here. We're finally out of a crazy minus 40 degrees Celsius cold spell that we had for almost 10 days straight, which, extended all the way down into Texas. And so, yeah, we live in a world where Texas is freezing, but that's due to global warming. We can just say, I mean, people just get away. So, someone somewhere has figured out that in science, you can just freely lie as much as you want. So, some group somewhere, somehow has figured out that you can just make bald-faced, obvious, plain lies directly in the heart of physics. I mean, the biggest possible lies in physics are would be these two things. If you were to postulate the two biggest possible lies in physics, and I'm not just making this up because it's coincidental. Really, you could probably ask any physicist this. Not that they would appreciate it, but these would be the two biggest lies in physics. One, flat earth theory. That would be the biggest possible lie in physics. And two, violating thermodynamics with reverse heat flow from cold to hot. Those would be the two biggest possible lies in physics beyond all imagination, the two worst possible lies. And what has happened is that someone has figured out how to do it, and they have done it with consummate ease, with the entire physics establishment defending it, defending flat earth theory, defending heat flow from cold to hot. It's amazing. Whoever figured this out, whoever did this, really quite genius. And they just don't care. The physicists just don't care, don't want to think about it, just because, it's been peer reviewed. So if you peer review that the solar power is 1/4 of the solar power, then I guess that's what it becomes. It's a very sort of herbivore mentality of things, or approach to the world or something. Okay, anyway, let's not get on craziness. All right, nice to talk to you all. Hope you like that. Please share my videos as much as possible. This has got to make an impact eventually somewhere. This is such basic, obvious things. Anyone can understand this. This has to have an impact at some point, at some place. Okay, so please help out. Just please share as much as possible. Like, you will be attacked. These people are vile. Climate scientists in general are the most vile and foul people you will ever meet. Like, the way that they will attack you, they will ad hom, they'll peer pressure, they'll insult your intelligence because you're saying, are you sure flat earth theory is correct? And they will attack you. So if you share my videos, don't worry about being attacked. I will take that. I am well seasoned. I've been doing this for a long time. I have thick skin. I can take all of that. So send it to me. If you share my videos and they attack you and they treat you in a vile, foul way where they want to destroy you and just do whatever they can to harm you, send it my way. I'll take care of that. I'll gladly take care of that. So anyway, thanks a lot, guys. Take care. Hope you're going to have a good weekend here. And okay, bye.